Hey everybody, this is Larry. This is day 24 of the Leetcode Daily July Challenge. Let's get started by hitting the like button, hit the subscribe button, and join me on Discord and ask me about this question and other questions. Let's go at all paths from source to target. So I'm going to solve this problem live. So watch it on 2x or something like that if you feel like you just want to go over the explanation. But I do want to go over like how I think about this problem. And this is me seeing this problem for the first time. Given a directed asynchronous graph of n nodes, find all possible paths from node 0 to node n plus 1 and return them in any order. The graph is given as follows. The node is, okay, they're just nodes. And then you have an edge list. And this is directed asynchronous, right? And the number of nodes could be 15. So what does that mean, right? Well, how many paths are there? Well, each node can only be in the path or not in the path. And because it's directed asynchronous, then you don't have to worry about cycles and stuff like that. And because it's directed, then you don't have to worry about back edges. So what that means is that, and you're given an adjacency list already. And so what does this mean? This means that each edge or each node can be or not be in the path, and what that means is that there are at most 2 to the n paths for this particular case, and because of that, you can use brute force. Is what I was going to say. You could use. I know that people kind of mix up the notation with calling it backtracking, but by calling it depth first search. But I want to say that it's more precisely backtracking because you reset the state at every recursion, and I'm going to walk you and me through this, so don't worry about it if the words are just words for now. We'll go for it now with the code. Let's go backtrack. You're given a certain node, and the node is just a node index, just to be more precise. And okay, we want to print the path. Okay. All right, let's just have an answer here, and then return the answer. For the purpose of being lazy, I'm just it's global. You can do some math, or you could pass a function around, you could pass the variable around to append and stuff like that. But for me, I'm not going to do that for now. So basically, what do you need, right? Well, usually I would say something like visited array, but well, because this is a directed graph, we don't need it because we're never going to visit the same node twice in the same path. And then the next thing we want to do is just keep track of the current path. So we do need to keep track of that. So let's do backtrack of is it always going to be 0? 0. Okay, 0. Okay, and maybe an empty array for the current path. Okay, so yeah, okay. Okay, so now let's do if index is equal to n minus 1. We can do stuff and we set n is equal to the length of the graph or the number of nodes. And what is the base case here, right? Well, the base case is just, well, now that we're given the path, we could put it in answer. So let's do that. And depending on your language, I would be careful here. And I definitely made this mistake many times where I just do something like this. And what that happens is that in some languages, it actually only copies the reference. And the problem is that every time you append, you append the same reference. And if you append the same reference, well, then it's just all going to have the same answer. So I just want to point that out. And also return in this case. So in theory, it should not have any edges anyway. But okay, and now just for re and graph of node index, I say re because of the UV convention, which is just a common thing in graph theory. Okay, so now for every node, we can just do backtrack the re and then path plus node. I think I'm missing something somehow. Okay, so I'm going to start with 0, and then here we just path to re. And of course, this actually creates a new. The way that we did it, it actually creates a new list so that we don't have to reset something. In traditional path backtracking, you might have to, append and then remove afterwards or something like that, to reset the state. But because because we actually create a new array or new list, we don't have to worry about that. And I think that's all we need really. So let's try it out. Yeah, so that looks good. Just an empty no list. I guess this is like this, but and I don't know, something like that. Okay, so I knew that that would happen if they don't have any nodes at all. So I guess we just have to do if n is, and I don't know if this is routed in. Oh no, the number will be 2 to 15. So I guess that's okay. Okay, so I think I'm ready to submit. Let's give it a go. Cool. Yeah, and again, the way that I would do an analysis is that it is exponential, it is backtracking, and is because of the way that we talked about earlier, there can be at most 2 to the n number of paths, which is 2 to 15, which is, you know, good enough. You could plug in a calculator if you want to figure out what's 2 to 15. I think it's like 32k or something like that. 33. But yeah. And in terms of space, well, the space is just going to be output sensitive, plus the of n for the stack length, which is going to be exponential because, or depending on the output sensitive part, because, well, you can't really do better than output sensitive because you need every answer. That's what this problem requires. Cool. So this is backtracking. This is a technique that is super helpful to definitely practice it. Yeah, let me know what you think. Hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye bye.